So now, in order to connect with the previous lecture, in this lecture, I'm just going to discuss some basic concept of conditional probability. So we have already explained in great detail the application of probability in decision making. Now you need to know the basic concept of conditional probability. So you can check this from the name conditional probability. Mean there will be some specific condition imposed, and you need to take that imposed condition, and on the basis of that you will use the existing information to find out the chance of winning or losing.
Conditional probability is basically used to determine how two events are related. That is, we can determine the probability of one event given the occurrence of another related event. So it means something will be known to you in advance. Then using the concept, using the information of the given thing, you will be able to calculate the probability of which they ask from you. So conditional probability are written as probability of A given B. So normally we write this A given B. Basically we want to calculate this probability and the B probability is given to you. So B means some condition which is known to you, which is known to us, and while using those information we will try to calculate the probability of A. So, and we can read is the probability of A given B, or mathematically we write it probability of A given B, and is calculated as probability of A given B, probability of A and B. So mean now you need to understand, and we already studied this rule, and rule. Normally we denote this with the intersection, probability of A intersection B. What are mutually inclusive? You people know what are mutually inclusive and what is mutually inclusive. So normally we write it probability of A given B is equal to probability of A intersection B divided by probability of B. We normally divide it with the given probability. So now in this case we will divide it with the given probability which is B, and we want to calculate this A. So how we will calculate this now while using the conditional probability? So I will in the coming slides I will solve some specific problem. So in order to try to clear you the concept of conditional probability, again the probability of an event given that another event has occurred is called a conditional probability. Probability of A given B. So we will calculate given that B is given to us. So we will write it mathematically probability of A and B divided by probability of B. If they ask you probability of B given A, so in this scenario, in this example, we have A is given to us, this condition is given to us, and we want to calculate B while using the given information. So mean this will be same, probability of A and B. If you write it B and A or A and B, this will be same because A intersection B or B intersection A will be same. But this will be different from this one because this is given to us, B is given to us. But in this case, A is given to us. So probability of A and B is equal to, you can also write it, probability of A into probability of B given A is equal to probability of B into probability of A given B. Both are true, keep this in mind. So mean I'm just going to show you how these are both same. So mean probability of A into probability of B given A. So probability of A into, how we will write this, probability of B and A, probability of A. So this will be cancelled with this. It will be probability of A and B or probability of B and A. So mean in both cases these are true. We will also use this concept in the coming question. So you need to understand. Okay, conditional probability. I just want to throw some more light on the conditional probability. You need to understand what is conditional probability. For example, diagnosis using a clinical test. Sample space. So this is our sample space. Sample space you already know, a complete test of all possible outcome. So in this case the sample space is all patients tested. All patients tested. This is my sample space. And we already defined two events. This is whole sample space, this rectangular yellow box. And these are two events. There is something common in both these events. Event A, which is showing subject has disease. Event B, test is positive. So how you will interpret this? Probability A intersection B. So how you will interpret probability? You can subjectively interpret this. Probability patient has disease and the test is positive. Yes, this is correct. You also know the concept of complement. Complement mean, for example, if we have a set 1, 2, 3, 4, 5, 6, B is 1, 2, so S minus B will be the complement set. Those items which are not included in B will be considered as B complement. So how we will? A intersection B. Subject has disease and test is, what will be the opposite of this? Because B's test is positive. So the opposite of this will be test is negative. So probability patient is disease but negative test. This is a false negative statement because how is it possible? The test is negative and the patient has disease, so I mean these are not true. But we will interpret this mathematical equation like this. Okay, this is A complement. What is A complement? The items which are not exist in A. Subject has disease, so means subject has no disease. A complement will be subject has no disease. And test is positive. Probability patient has no but positive test, which is also false. Now this is conditional. How you will interpret this? How you will interpret this? Probability patient has disease. What is B given to you? So this is given to you. Probability patient has disease given a positive test. So means subject has disease given what is given to you? Given a positive test. Okay. This is given a negative test. Probability patient has disease. So mean you need to calculate probability subject has disease given that a negative test. So you can interpret it like this way. Okay, I am just going to solve some more example to further clear to you the concept of conditional probabilities. This is another rule, just like we already studied for two independent in the previous lecture. Probability of A intersection B will be equal to probability of A into probability of B if A and B are independent. So in conditional probability, this rule is a little bit changed. If two events are independent, then probability of B given A can be written as probability of B. How? I am just going to explore this. Probability of B given A will be equal to probability of A intersection B divided by probability of A. Further, because if two events are independent, so you already know how we can write it. We can write it probability of A into probability of B divided probability of A. This A will be cancelled. It will be equal to probability of B. Similarly, if A and B are independent, then probability of A intersection B divided probability of B. So A intersection B can be written as probability of A into probability of B. So B will be cancelled with this probability of B. So this will be equal to A. So you need to understand this independent rule, and you also know what is dependent and what is independent, because I already discussed the dependent and dependent example in every of my lecture. So let's start a simple example. A fair die is thrown. What is the probability that the number on the die is 6 given that the number is even? So when you throw a die, so first of all you need to understand, you need to construct the sample space. Sample space will be 1, 2, 3, 4, 5 and 6. This is your sample space. Now further, what is the probability that the number on the die is 6? Let A is the event that show the number is 6 and B is the event given. Something is given to you in this example. So this is not a simple probability question. This is conditional probability, because in the question it is mentioned what is the probability that the number on the die is 6 given that the number is even. So how many even are in the when you throw a die? So we have 2, 4 and 6. These are 3 even number. So now the question is, what is the probability that the number on die is 6 A given that the number is B, the number is even? So how you will write this? Probability of A intersection B divided probability of B. So first of all you need to calculate A intersection B. What is common? So A is only one element. The number appear on the die is 6. So 6 and this is also 6. So we have only one element which is common, which is mutually inclusive between A and B. So what will be the probability of 1 by 6? So 1 by 6, probability of A intersection B will be 1 by 6. divided by probability of B. So how many? 3. Probability of B will be, probability of B, how many number in the set B? 3. And total number 1, 2, 3, 4, 5, 6. So 6. 3 by 6. This will be cancelled. So the answer will be 1 by 3. So mean conditional probability is not difficult, but something will be known to you, something will be given to you. They will impose some specific condition on specific trials. Then on the basis of that condition, you need to solve, you need to calculate the probability. Okay, there is another example. The probability that a particular flight depart in time. So probability depart, let's suppose we denote depart with D, 0.70. And the probability that flight arrive in time. Probability, let's suppose A represent arrival. Okay, which is 0.75. The probability that the flight depart and, so you can see this end, you can see this end, probability depart and arrive is 0.67. So you can write this probability of depart and arrive is 0.67. If the flight has departed in time, now if the flight has departed in time, this is known to you. If it departed in time, then what is the probability? What is it? It's also arrive in time. So arrive, given that if the flight departed in time, what will be the probability that it will also arrive in time? So probability of A intersection D, probability of D. So probability of A intersection D or D intersection is same, 0.67, and probability of D is 0.70. So you can easily calculate this probability. There is another question. Now we will further go into some complex question, because now I am hopeful that you understand the basic meaning of conditional probability. In conditional probability, something is known to you, and now you know the basic rules, the basic laws in conditional probability. There is another question. In a firm, 20% of the employees have accounting background. So let's suppose A represent accounting. How much? 20%. While 5% of the employees are executive, and so once again something is common, they have accounting and executive background. How much? Accounting and executive, E represent executive, which is 0.05. If an employee has an accounting background, this is known to you now. If an employee has an accounting background, then what is the probability the employee is an executive? So probability executive given that accounting. So probability of E intersection A, probability of A. So 0.05, 0.20, you can easily calculate the answer.